Some time ago, I gave a lecture at a college in Peshawar on the origin of the universe. At the end, a student put up his hand and he said, "Sir, is it true that the Big Bang started in Mecca?" I said, "Of course. But it also started in Karachi, in New Delhi, in New York, in Las Vegas. In fact, the center of the universe can be anywhere." He thought that I was being funny. After all, a circle has only one center, and a sphere also has only one center. So it doesn't seem to make much sense. But today, I'm going to try and persuade you that it does make sense. I am serious. Well, let's rethink the Big Bang. We see the galaxies moving away from us. And this was known 100 years ago. Today we know it even better and have measured their speeds as well. Now, if we were to move all those galaxies backwards, it would seem that they're coming from one single point, that single point being, of course, the Earth, where we observe from. Now, that puts us in the position of maybe 400 years ago and earlier, when people used to think that the Earth was the center of the universe, that the sun goes around it. And when Galileo Galilei had said that no, it is the Earth that goes around the sun, the church had sentenced him to death. More recently, just a few years ago, or rather a few decades ago, Sheikh Abdullah ibn Baz, who was rector of Mecca University, made the claim that indeed the earth is stationary and the sun and the moon go around it. He wrote a book called Jiriyan al-Shams wa Qamar wa Sukun al-Arz. And he said, whoever doesn't believe this is not a Muslim. To understand why every point in the universe can be the center, I'm going to give you a little demonstration which will make this clear. So I have this balloon which I'm going to blow up, and I've put little dots on it which are supposed to represent ants that live on the surface of the balloon. As the balloon becomes bigger and bigger, you see that the dots or the ants are moving away from each other. So ant number 1 would say, ant number 2, 3, 4, 5 are running away from me. But ant number 2 would also say, ant number 1, 3, 4, 5 are moving away. Every ant would be justified in thinking that it is fixed, everybody else is moving. But what's the thing that we are located upon? What is it that's moving outwards? In the case of the ants, they were just living on the two-dimensional surface of a balloon. What are we living on? The answer will require us to discuss the nature of space and time. So let me first take space. We measure space with a ruler or some other means of measuring length. And so how long an object is depends upon how much space it takes on this ruler. You and I will agree, and we expect that a third person over there will also agree with us. Similarly for the nature of time. So let's take this pendulum, which let's say takes 1 second to complete one period of oscillation. Now, you and I would agree to this, and we'd expect that a third person will also agree that it takes 1 second. This is just common sense, but Einstein showed that, in fact, this is not true, and that what another observer may see, both in terms of length and time, can be different from us. He showed that if an object is running away from us or towards us, so for example, if you take this ruler, if this ruler is moving towards me very, very fast, close to the speed of light, that it will appear shortened to me. And similarly, if that pendulum, which I just showed, is moving towards me very, very fast, then I will see its period lengthened. In other words, its time will appear stretched out, dilated. Einstein also showed that space and time can become curved. Now, that's not something that I can explain easily without mathematics, but this is something that has very definite observational consequences. So, for example, Einstein showed that a heavy body curves space and time around it, and the heavier it is, the more it curves it. He considered the following situation. Let's say that there is light which is coming from a distant star past the sun. Now, the sun is very, very heavy, and it curves the space-time around itself, and so the ray of light is deflected. Einstein was able to calculate the amount of deflection, and then there was a very famous expedition that was carried out by Sir Arthur Eddington, which confirmed that this was exactly what he had predicted. So when the observation and the prediction were shown to match exactly, Einstein's theory got a huge boost. Einstein also showed that if light goes against the gravitational field, it slows down. In other words, there is a change in the frequency of the light. This is exactly what is seen when a radio signal is sent from the ground to a satellite which is orbiting the Earth. And in fact, the accuracy of the GPS system depends upon this. Einstein's theory, and this goes back to 1916, was picked up by scientists around the world, and they got various consequences from it. The most important one, I think, was that which was developed by three scientists, Friedman, Walker, and Robertson. And they showed that space-time itself can expand as a sphere outwards. This expansion of space-time is precisely the expansion of our universe. The surface upon which we live, the surface upon which all the galaxies are located, is space-time itself, and space-time is expanding. Now that I've tried to clarify what the expansion of the universe is all about, the question is, will this universe and the space-time in which it is located continue to expand outwards? Will it do so forever, or will it come to a stop? Will it reverse its expansion? In other words, what will be the fate of the universe? That's something that we're going to come to in our next episode.